GM, how we doing today, everybody? Welcome. Thanks for your patience here. Welcome to the Vyper kickoff call, the Vyper compiler kickoff call, where we fantastically got an additional $10,000 right at the buzzer. Thank you, Uno Ray, for the additional 10 grand in donations. We have a $160,000 Vyper compiler audit competition. And I'm especially excited for this one. Especially excited for this one for a number of reasons. Number one, well, Brownie, Python, Vyper has been one of these massively important things to me in getting into Web3. It was Python that really got me excited about financial technology in general. And it was the Python tooling in the EVM world that really brought me in and was able to get me, spun up. And then additionally, this is going to be a difficult contest. This is a compiler. This is not something that we've done before. This is going to be hard, which makes it even more exciting. Right? There have not been contests like this historically. There have not been contests like this in the past. But the thing to remember, if it's hard for you, that means it's hard for everybody else. So just keep that in mind. At the end of the contest goes to November 6th. It starts technically last night / today. Goes to the 4th of November. Once it ends, that money is being given out. So are you going to rise to the occasion? And obviously you're helping secure one of the most important languages in the Web3 ecosystem. Vyper currently handles, I think, around 3 billion TVL. So we're very excited for that. So with that being said, though, I believe the lead Vyper dev has arrived, Mr. Big Tech Sucks himself. I'm going to add him to the stage now. Hello, Mr. Big Tech Sucks. How are you today?
Hello. Can you hear me?
Loud and clear. How are you?
Good. How are you?
Doing quite well. Excited to be talking about Vyper. Excited to be having more people look at Vyper.
Yeah, same.
So before we jump into kind of a little bit more about the competition, I wanted to hear from you. And I know we didn't really ask any questions. Oh, it looks like you did ping me. I know we didn't ask any questions. I didn't prep you for anything, so sorry about that. But I wanted to hear from you. So why do you think Vyper is such an important piece of infrastructure for Web3?
That's a really interesting question. I think that Vyper is really important for a couple of reasons. One, we're innovating a lot on a lot of fronts. So we've got the Titan interpreter, which is a native interpreter for Vyper. We have, kind of a new intermediate representation pass, which is like kind of, I want to say like the cutting edge of like actually development or research for compiling for stack machines. And then also DevX is really important. So we want it to be easy to write, clean, maintainable code, and having Python as our base, makes it really approachable for a lot of people who want to write smart contracts that already know Python really well. I mean, it's not one-to-one Python, of course, but it's based on Python, so it looks familiar, it feels familiar, and right now our focus is on DevX and making a really enjoyable to use smart contract language.
Definitely 100% agree. Yeah, and so you mentioned a couple things there that I wanted to pull up. So let me share my screen here. Titan Boa. So you mentioned this this tool called Titan Boa, and a lot of the auditors here are going to be really familiar with Foundry. A lot of them are going to be less so familiar with Titan Boa. How would you describe it? So I usually tell people Titan Boa is kind of the Foundry of the Vyper ecosystem. Would you say that's an accurate analogy here?
Yeah, I would say so. It's similar in some respects to Foundry because it feels native. It doesn't require an external node to run, so everything runs actually in an embedded EVM, which is PyVM, but that's theoretically swappable actually. And the difference with Foundry is that your test code is actually written in Python, so you're still testing Vyper code from Python, but the friction between the two languages is designed to be as low as possible. So it feels like a very close interop.
And so for all of those who have been paying attention to the Web3 education site, we have some plans to do some BOA teaching because it's crazy fast. Now for this compiler competition, obviously you're not actually going to be looking, well, you might be doing some looking at Titan BOA, but you're probably not going to be looking at Titan BOA. You're going to be more so looking directly at the Vyper code, right? And if you're looking at the repo, we have that here. Let me actually send this in the chat. This is the official repo for the competition. You can also go to the Vyper GitHub, of course. And if you're on the Vyper GitHub, you can actually read in the contest details. It's going to be the same code as what's in 0.3.10 RC3. So this is a brand new release candidate edition of Vyper. There is no, well, hopefully no production code of this. There's hopefully no production code of this. Brand new piece of code, and you can kind of flip either between this repo here, this has all the exact same code, or you can just go right to the Vyper Lang Git repo and then flip over to that. So this is mainly what you're going to want to be playing in. And for those of you who are doing this, obviously, you can see, if we scroll down here, yes, this is all written in Python, which a lot of you were actually surprised to hear, which was surprising to me that it was surprising to you that a Pythonic language was written in Python. Charles, can I ask too, why Python? Like, I feel like there's some sentiment, oh, okay, cool. If you write this in Python, it's going to be really slow. It's not going to be very performant. Yet, if anyone's actually used the Vyper compiler from the CLI, it's crazy fast. You know, why did you choose Python to write this compiler? Or excuse me, not, I guess you didn't choose to do it, but why is Vyper written in Python? What was the rationale there?
Yeah. So first of all, Vyper is not a fast compiler. I mean, it works well enough for smart contracts, but compared to probably most other compilers, it's fairly slow. But from a DevX perspective, you don't really notice, and also you don't really care that much. When you're writing smart contracts, you care more about the performance of the bytecode that's emitted. So, actually, I've asked people about this, and the feedback I consistently get is, we don't care how slow the compiler is. We want the bytecode to be really good. So that's just to state that, the performance isn't that big of a concern. Why Python? Python is a very readable and very, very, very productive language. The entire Vyper code base, at least kind of the important parts, the semantic analysis and code generation, are like 10,000 logical lines of code. And Titan BOA, which is like basically a fully fledged testing framework and is at least feature parity with Foundry, if not more, is like a couple thousand logical lines of code. So Python is very, very productive. It's a standard. A lot of people like it and use it and love it, really. And people ask about dynamic typing and stuff like this. But when you're designing a compiler, I think what's most important is actually kind of the data structures you use. And I can go into this more if you want. I can go talk about this at length. But basically, the way that compilers work is actually very conducive to using a dynamic language, because you're like iteratively kind of annotating this AST analyzing it, and then like generating some downstream code. So it just lends itself very well.
Yeah, that makes a lot of sense. And so we have 15 minutes to get these people as hyped and as prepped for this competition as possible. So if we want to get nerdy, Charles, we get nerdy. All right. If you want to talk at lengths about something, we can talk about lengths about something. So what you're saying though makes a lot of sense. Hey, like we want to have good code, and there's the tooling here is really freaking good, right? So one of the things that I did want to go into for all the people who are going to be auditing this, the question that a lot of them have is, okay, like how do I even start? Like how do I even start to begin to audit this monstrosity, right? Obviously, this is a long competition, right? It's a month and a half, right? This is longer than most audit competitions out there, which makes sense. There's a lot of code here, right? So what would you say to some of the people who come to this, they're feeling a little bit overwhelmed? Like where would they start? Like is there a folder they should go into? Obviously, they should try to set up the environment first, but where should they start? Where should they look?
Yeah, there's some internal docs on the design internally of the compiler. But I would say that you want to, most of the entry points into the compiler are in this Vyper/compiler/phases file. And that basically, yeah, you got it. And that basically outlines the major phases of the compiler. It gets fed. There's different entry points. There's the CLI, there's the JSON input, but eventually they all go here. And it just takes basically source code and some, kind of required metadata that it needs to run things. And then it goes through all the phases. So you'll see here that, we take the AST, we do some constant folding, we do some semantic analysis, and then do other AST kind of expansion operations, and then go into code gen, and then finally emit bytecode. So I think that's a pretty well laid out description of like how the compiler goes through the phases.
So we have kind of this docs here, right, in the compiler folder, compiler phases. So first off, in the Vyper.ast, the source code is parsed and converted to the abstract syntax tree. Yep, like you were saying. Then we have some folding. Object is generated from a Vyper. A global context object is created, and organizing the nodes prior generation. I feel like to a lot of people, this is going to be a little bit of gibberish to them. So that's going to be kind of exciting. So for those of you who are not familiar with AST, you're not familiar with compiler IR. Actually, why don't we start there, Charles? What is AST, and then how does it compare to something like Solidity?
Sure. So these are kind of common phases in compiler construction. You start with source code, right? That's like code that you know and love, right? It's like Vyper source code, and you know how to read it, and it's got like function definitions and all these kinds of things that look kind of Pythonic. And the first thing you do basically is you parse it into some, but it's also machine readable. So the first thing you do is you parse it into a tree data structure, which is called usually an abstract syntax tree. And then from there, you kind of analyze it. Analyzing means a lot of things, but basically you need to find out what the code actually means. And one of the main thing you do actually in analysis is type checking. But you also do some other things like figuring out where storage variables should go, and there's some details about where different variables go, how functions are called, it classifies functions and so on and so forth. So that's all called analysis. And then from there, you go into what's called an intermediate representation. And the reason that compilers that IR is the common shortening for it. And the reason compilers use an IR is because it's basically it's a kind of encapsulation. So it turns out that popping up a level. It turns out that if you try to go straight from AST to like bytecode, it gets kind of messy because your code can't be very modular. Um, so over the years, what people have found that is better to do instead is go through an intermediate phase called an intermediate representation, and basically that's like it's like more abstract than bytecode. So it hides things like stack access, um, low level jumps or go tos, and exposes some like simple like variables, control flow, but it's at the same time it's much simpler than user code.
So can I, if I may, so it looks like at a very, very high level, the first step of the Vyper compiler is create this AST, right? This abstract syntax tree, which is kind of a big word for, how do I overly simplify this?
It's a tree data structure representing the code, and
So,
and it's more or less 1-to-1 too.
yeah. Okay, cool. So we make a tree data structure representing the code. That's the first thing we do, and we do some type checking and some other stuff, and then we do this next step, which is to take this kind of very human readable code and move it to a slightly less, like almost like a middle step, also known as the IR. Does is the Vyper compiler IR like officially known as Venom, or is it still just like compiler IR right now?
Well, we're completely redesigning it, so that's a kind of
Got
fun
it.
question.
Good.
So the new IR is called codenamed Venom. So we're calling it Venom 1.0, and then this is like Venom 0.1 because it's the existing thing.
Hmm.
And then
Okay.
and then the tool for compiling Venom is called Fang.
Got it. Got it. So we do the AST, we compile to this IR, this Venom, and then we move to actually the EVM code. Those are the op codes. This is the push. The Why is push the only opcode that's coming to mind
Yeah,
right now? Call data, all the other stuff.
yeah. There's actually another intermediate step. There's a couple intermediate steps actually. So you take the IR and then you actually optimize it, and it's like way easier to. One reason that IR is useful is it's way easier to optimize IR than either source code or bytecode. IR is usually specifically designed so that it's fairly easy to emit, but mostly so that's easy to optimize. So it's optimized, and then you emit what's called assembly, and assembly is actually close to bytecode, but it's not exactly the same. The main difference between assembly and bytecode is that in assembly, jump destinations, so labels are kind of abstract. And the reason is that when you have bytecode, you need to actually jump to physical locations. But when you are assembling the code, you want abstract locations. So when you emit IR to assembly, you want the assembly to have like these labels in it, which are like names instead of like fixed locations in the code, because like as you transform the assembly or whatever, those locations can change. So those are abstract. And then finally, at the last stage, uh, you have what's called assembly. The assembler takes assembly and assembles it into bytecode. And the main thing that happens there is finally all these locations that were abstract before in the bytecode are like fixed, and then you emit actual like push, pop, dupe instructions and jumps, calls, or whatever.
Gotcha. Cool. Well, very helpful. I have one more question here, and then we can wrap up, and everyone get back to auditing. So it says this in the documentation, but I wanted to ask for everyone here listening as well. Where should they be looking? Where are they going to find bugs? Where are they going to find issues, if there are issues?
I think the most important issues, like critical issues, are kind of issues where access control isn't really protected, or like basically if you have a contract and then it doesn't just like stop working, but like a user of that contract can make it do something that the user wants that it's not supposed to do. And those are probably mostly actually going to be in access control. So this has to do with like how storage is allocated, cryptographic primitives if they're being used to perform access control checks. In the selector table, which is a data structure, well, it's actually a code structure, which takes call data and figures out where in the contract to enter into. And if that has some bug in it where you can like enter into a private function instead of a external function, an internal function instead of an external function, that would be really problematic. So those are kinds of the areas I would go towards.
Gotcha. Thank you for the context there. Additionally, if you go to the repo here, we scroll down all the way down here. Yeah, these code gen and optimizer sections are going to be really, really important because those are going to be where creates the EVM the EVM code. So I should probably add something in here where we're saying also access controls. Is that right?
Yeah.
All right, cool. I can add that after the call.
Yeah, I mean, access controls is actually like kind of more high-level description of the things that we're looking for. So it could be in the code gen, but it might also be somewhere else.
Gotcha.
But what we're really looking for is those things which hand control to a user of the contract where they shouldn't have it.
Gotcha. Awesome. All right, well, very exciting. Well, we have a couple minutes left here. So again, for those of you watching, you can find the contest details obviously on CodeHawks. Everything is in here. We started already. We started at midnight of today, ending November 4th. So you have 50 days, 10 hours left. And as we said before, $160,000 up for grab. Huge thank you to the sponsors of this protocol. Lido, Yearn, Curve, Cypherin, and Uno Ray for bringing this, making this come together. And then obviously to the Vyper team, obviously to Charles for being the lead Vyper dev, making this all kind of possible. If anyone's been following along the Vyper GitHub, which you should be, you can see Charles is just kind of a madman, creating PRs there all the time. So huge thank you to the Vyper ecosystem, to Charles, to everybody for coming together and getting this up so that we can absolutely just kind of run train on the Vyper compiler, get us up to speed get us up to speed with a security review, and everyone who's watching this be able to learn more about compilers in general, obviously, and then the Vyper compiler. There's a ton of Vyper code coming down the pipeline in the EVM ecosystem, and we're very, very excited for that. So we have about 2 minutes left here. Is there anybody from the audience who is listening right now? Anybody have any questions that you want to ask? Obviously, Charles is the number one guy to ask a Vyper question to, and then obviously, compilers in general. And I should put this in the chat as well. If you're looking to watch a video kind of on a high level of some of the differences between Vyper and Solidity, I have this video that I made on a different YouTube channel called Chain Dev, where we look at some of the high level stuff underneath the hood. I'll drop that into the chat as well. Some of the high level differences, because that's going to be one of the main questions a lot of you ask. Hey, what are some of the main differences? And the two languages, surprisingly enough, even though they both compile to EVM, they make a ton of different opinions and architectures underneath the hood. So that's going to be really exciting. So, but before we jump off, are there any questions that anybody has? Now's your time to ask Charles about Vyper, about what to look for, about auditing the compiler, about compilers in general, about the Vyper ecosystem. Are there any questions that anybody has here? All right, got some people being very excited. That's great. Love the challenge. Excellent. If you don't have any questions, that either means you've already found bugs or you have no idea where to start. I'm betting the latter. And then, of course, you can always ask questions in the Discord channel on Vyper as well. All right, cool. Well, if there are no more questions here, if there's no questions, then all I want to say is, they don't want optimizations, right? No, for this competition, we're not looking for optimization. Charles, do you want to have people submit optimizations? So as the details are written, we're not paying out optimizations. But if you want to submit them, Charles, are you interested in looking at optimizations?
Yeah, optimizations to the compiler could be helpful, as well as any optimizations to emitted bytecode.
Cool. So if you want to submit optimizations, great. For the competition, those aren't going to be rewarded, but absolutely, yeah, send those over. Or if you want to just make a PR for optimizations, that's great. Only high mediums, no. So it's actually high mediums and lows. If we scroll down to severity rating, we actually give a couple examples of high, medium, low. So yeah, so high, mediums, and lows. And you can see the prize pools. If we scroll up here, high mediums are 95% of the prize pool. Lows are 5%. So we're going to wait for the next version of Vyper to come out before making the next bootcamp. At this point, probably. Yeah, at this point, probably. Good question. Any other questions? All right, cool. Well, sounds like there are no more questions. Thank you all for coming. Best of luck in the Vyper audit competition. We are incredibly excited for y'all to get going on this. This is like, I'm so pumped that all of you are going to become compiler savants and learn about the Vyper ecosystem as well. So, Charles, anything else you want to say before we jump off here?
Not really, but thank you, Patrick, for hosting me, putting this all together, hosting the competition. Really appreciate everything that you've put in for Vyper. So yeah, I'm really excited for this competition.
All right, snake friends. Vyper time. Good luck, and we'll see you soon.